In this video, we'll be looking at exponential equations, where our focus is going to be on exponential equation leading to linear equation. And so, if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we start with the meaning of exponential equations. An equation involving powers of numbers is called an exponential equations. So example, we have 2 exponent s is equal to 8, or 4 exponent m is equal to 2. And so if we see anywhere an equation of this form, then we can term it as an exponential equations. So we have exponential equations leading to 1, linear equations, 2, quadratic equations, and 3, simultaneous equation. But today's video will focus on exponential equation that leads to linear equations. And so let's continue. So an exponential equation leading to linear equations. So we are saying that if we have a base a and it has an exponent of x, which is equal to another base of a and has an exponent of y, then we are saying that provided a is not equal to 0 or 1 or -1, then we can say that since the base are the same, then we equate the exponent. Since the bases are the same, then we can equate the exponent. So if that's the case, then we can say s is equal to y. In the same way, if we have m exponent p, which is equal to m exponent q. Now we are saying that provided m is not, so we are saying that provided m is not equal to 0 or m is not equal to 1 or m is not equal to -1, then we can see that once the base are the same, then we can equate the exponent. So we have p to be equal to q. And so that is the exponential equation, how it starts and how we can deal with it. And so having known these bases, let's see how we can solve equations or question on that. So example 1, it says if 3 exponents s is equal to 9, find the value of x. And so we can solve it as, so we first write our question, that is 3 exponent x is equal to 9. So the idea here is that we have to simplify the left hand side of the equation and the right hand side of the equation such that they become, or they have the same basis, and then we go ahead and equate the exponent. So if that happens, then we know that we can express 9 as 3 exponent 2. That is 3 times 3. That gives us 9. And we know 3 times 3 is the same as 3 exponent 2, which is equal to 9. So if that happens, then we can write 3 exponent x to be equal to 3 exponent 2. So right now that we see that the bases are the same, then we can equate the exponent. So that's s is equal to 2. Now we move to example 2, and in example 2 we have given that 3 exponent x plus 1 is equal to 9 exponent 4, find the value of x. So we have our solution as, so that is 3 exponent x plus 1 is equal to 9 exponent 4. Now with this, we have to express the left hand side and the right hand side such that they have the same basis, and fast forward, we equate the exponent. So we know 9 can be expressed as 3 exponent 2. So if that's the case, then we have 3 exponent x plus 1 is equal to 3 exponent 2, that is equal to 9, and we bring our exponent 4 here. Now we continue, and at this point we can multiply the exponent 2 and 4 here. So we have 3 exponent x plus 1 is equal to now 3 exponent 8, because 4 times 2 is 8. So having known this, then once the base are the same, we can equate the exponent. So our solution now becomes x plus 1 is equal to 8. So in solving for x, we have x is equal to 8 minus 1, and henceforth s is equal to 7. Now we continue and we move to our next set of examples, and we have find the true set of the equation 8 exponent x minus 2 is equal to 2 exponent x minus 8, where x is a real number. So in this sense, let's first write our solution. And so we have 8 exponent x minus 2 is equal to 2 exponent x minus 8. And so, like we've said earlier, we'd have to express both sides of the equation such that they all become, or they all have the same base. Then from there we equate the exponent. So if that's the case, we know 8 can be expressed as 2 exponent 3. That means 2 times 2 times 2, that is equal to 2 exponent 3, is the same as 8. So with that ideology, then our solution now becomes 2 exponent 3. Then we bring our existing exponent, that is x minus 2, which is equal to 2 exponent x minus 8. So we maintain that. Now, once the bases are the same, we can see that we can simplify the exponent, and so we can multiply the exponent, and as we have 2, we maintain the base, and 3 multiplies x, we have 3x, and 3 multiplies 2, we have 6, which is equal to the term we have on the right hand side, that is 2 exponent x minus 8. Now if that's the case, then once we see that the bases are the same, we go ahead and we equate the exponent, and as we have 3x minus 6 is equal to x minus 8. And from here we just make x the subject. So we have 3x minus x is equal to minus 8 minus, so it's minus 6. When you cross the equal sign, it becomes positive. And as we have 2x now to be equal to minus 8 plus 6 gives us minus 2. And so if you continue with our solution by dividing here by 2 and dividing here by 2, then we have our answer to be equal to s to be equal to minus 1. Now this is our solution to the question. So we continue with the next example, and we have if 8 exponent x minus 2 is equal to 4 exponent 3x, then find the value of x. And so we have been given 8 exponent x minus 2 to be equal to 4 exponent 3x. Now we are saying that we have to express the terms at the left hand side and right hand side such that they have the same base. And so we can express 8 in terms of 2 exponent 3. We can also express 4 in terms of 2 exponent 2. So if that happens, then we have 2 exponent 3, and our existing exponent as x minus 2 multiplied by the exponent 3 is equal to, now 4 can be written as 2 exponent 2. Then we bring our existing exponent as 3x. Now if that continues, then we can see that we can multiply the exponents both at the left hand side and at the right hand side. So we maintain our base 2, and when 3 multiplies s, we have 3x, and when 3 multiplies minus 2, we have minus 6, which is equal to 2, that is the base, and when 2 multiplies 3x, we have 6x. Now that we can see that the bases are the same, we can go ahead and and equate the exponent. Once the bases are the same, we go ahead and equate the exponent. So we have 3x minus 6 to be equal to 6x. And so from here, we just make x the subject. So in that sense, we just group like them. So we have 3x minus 6x is equal to 6. So from here, we know 3x minus 6x is minus 3x, and we have here to be 6. So we just divide both sides by minus 3, the coefficient of x, and minus 3. And when minus 3 cancels minus 3, we have x left. And so minus 3 cancels itself 1 and goes into 6 minus 2. And so x now is equal to minus 2. Now we continue with the next set of examples. And with that one too, we have, for example 5, it says find the value of x if 2 exponent x plus 2 times 8 exponent x is equal to 1. And so we have been given 2x plus 2 times 8 exponent x to be equal to 1. So as usual, we'd have to express the terms here such that they have the same basis, and from there we equate the exponent. And so 2 cannot be expressed to any other base apart from itself 2. And so when we look at 8 here, we can express 8 in terms of 2 and an exponent of 3. And so we do that. So we have 2 exponent x plus 2 times, now at this point 2 exponent 3 is the same as 8, and we bring our x here, which is equal to 1. And so when we simplify, then we have 2 exponent x plus 2 times, now when these two exponent multiplies, we have 3x, so 2 exponent 3x is equal to 1. Now let's look at this point, at the 1. We said that in the properties of indices, we said that any non-zero number which has an exponent of 0 is equal to 1. And so if we have 2 exponent 0, then we are going to get 1. So since we have been able to express the other terms in terms of 2, then we can express the 1 as 2 exponent 0, because we know 2 exponent 0 is the same as 1. So then we can have our equation as 2 exponent x plus 2 times 2 exponent 3x to be equal to 2 exponent 0. So now we've been able to express the equation such that they all have the same basis. Once we have done that, then we now go ahead and simplify the exponents and equate them. Now in indices, we said if the bases are the same and at the same time the bases are multiplying, we write one of the bases and we add the exponent. So then what we are going to do here is that we write 2, that is one of the bases, and we add the exponent. So we have x plus 2 plus 3x, which is equal to 2 exponent 0. Now we can simplify the exponent at the left hand side, and we have 2. So we have 4x plus 2, which is equal to 2 exponent 0. So right now that we've seen that the bases are the same, we go ahead and equate the exponent. So now we have 4x plus 2, which is equal to 0. And so in solving for x, then we have 4x to be equal to, now we bring the 2 to the other side and we have minus 2. At this point, we divide both sides of the equation by 4, and we have divided by 4 divided by 4. So this 4 cancels that 4, and we have x to be equal to minus half. And so this is the solution to the question now. Now we move to the next question, and we have example 6. That is, if 3 exponent x minus 2 is equal to 1 out of 81, find x. Now we know that we have to express the question such that they all have the same base, and from there we can equate the exponent. Now if that's the case, we said in indices that 1 out of a can be written as a exponent minus 1. And so by comparing, we can see that 1 out of a to 1 can now be written as a to 1 exponent minus 1. So if we have this in mind, then our solution can be written as, so we maintain the same value for the term at the left hand side, and we have 3 exponent x minus 2, which is equal to, now at the right hand side we have a to 1 exponent minus 1. So with this, then we can express the a to 1 for it to have a base of 3 and then an exponent of 4, because 3 exponent 4 is equal to a to 1. So we have 3 exponent x minus 2 to be equal to 3 exponent 4. Now we have our existing minus 1 as the exponent, so we bring it. Now we can simplify the exponent at the right hand side. So at this point we have 3 exponent x minus 2, which is equal to 3 exponent minus 4. Now with this done, then we can see that the bases are the same, so henceforth we equate the exponent. So if that is the case, then we have x minus 2 is equal to minus 4. So we find x by sending the minus to the other hand side of the equation, that's the right hand side. So now x becomes minus 4 plus 2. Now s is equal to minus 4 plus 2 is minus 2. And this becomes our solution. Now we go to the last set of examples for this video, and then we have find the value of x if 8 exponent x is equal to 0.25. Now with this one, just like we have been saying earlier, we just have to express this equation such that they have the same basis, and from there we equate the exponent. So we have 8x exponent s, which is equal to 0.25. So with this, we know 0.25 is the same thing as 25 out of 100. So we have 8 exponent x to be equal to 25 out of 100. Now 25 out of 100 gives us 0.25. So with this done, then we know that 5 goes into 25 1 and goes into 100 4 times. So that means we are going to have 8 exponent x to be equal to 1 out of 4. Now with this, we have to express the 8, that's the base here, and the 4 to a common base so that we can equate their exponent. So if that happens, then we are going to have, now 8 can be expressed as 2 exponent 3, and we have our x as the exponent here, so we write it here, which is equal to, now 1 out of 4 can be expressed as 2 exponent 2. So at this point, when we multiply the exponent at this side, then we have 2 exponent 3x, which is equal to 1 out of 2 exponent 2. Now in indices, like we said earlier, if we have 1 out of a, then we can express it as a exponent minus 1. So in the same way, if you have 1 out of 2 exponent 2, then we can express it as 2 exponent minus 2. So having known that, then we can say 2 exponent 3x is now equal to 2 exponent minus 2. And so we can see that since the bases are the same, then we go ahead and equate the exponent. So thus we have 3 exponent x to be equal to minus 2. So at this point, divide here by 3 and also divide here by 3. And so when 3 cancels 3, then we have x to be equal to minus 2 out of 3. And so this ends our set of videos for today. And thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. BakoMaths, thinking beyond infinity.